All right. Hello. Today I'm going to be talking about the different definitions of acids and bases. Okay, so there are three definitions, three different types. Um, the first one here is the Bronsted Lowry base. Okay, the Bronsted Lowry base accepts protons. I will be giving examples after I give you these brief definitions. The next thing is the Bronsted Lowry acid, and that one donates protons. Okay, now the next one I have here is the Lewis base, and what that one does, it focuses on electron movement, so the base donates electrons, while the acid accepts electrons. Okay. The next one is the Arrhenius base, and that one focuses more on aqueous solutions and what is it going to be increasing. Okay, so for the base, it dissociates hydroxide or OH in water. And for the acid, it dissociates hydrogen in water. So as you can see, this one focuses more on aqueous solution. This one is more of electron movement, and this is for protons. So that's why we need all these definitions to accumulate to what these bases and acids are, really which conditions there are under. So let's do some examples underneath so that you have an idea what they're really about. Okay, so for the Bronsted Lowry acid and base, we're gonna do, give me 1 second. Okay, so sulfuric acid, we're gonna do this plus water. And make sure that you know these definitions because they are most likely going to be in many multiple choice questions usually. So if you just know this table, you're able to answer those multiple choice questions with confidence. So right here, as we said in previous videos, I said that the conjugate, when you're doing Bronsted Lowry, the conjugate is going to be on this side. Okay. And over here, we see that it has more H's, so it's going to be your acid. On the other hand, the other one is going to be your Bronsted base. Now for the HSO4, it's going to be, if you can see these hydrogens, there is less. So that one is going to be the base, conjugate base, right here. Okay. And the other one, we are going to have a Bronsted Lowry acid because it has more hydrogens. If you need more practice, you can refer to my other videos. I show you more examples if you like to work on it. Okay, so again, Bronsted Lowry accepts proton, donates proton for the acid. And the next thing is the Lewis. Let's see, we do an example on that one. So NH3, obviously, it's going to have a lone pair. Just remember Lewis. I don't know, this might help you. Remember, Lewis has an E. So remember, it focuses on electron movements. So if it's electron movements, know that the base will donate and the acid will accept. So this is going to go here, attack this one. So this is going to be our base. We said it's donating, right? This is going to be our base. This is going to be our acid. Therefore, it makes an H4 right here. Okay. And the last one, the Arrhenius. Let's see here. Let's do an example. Because it's dissociating, okay, for the base. Let's start with the base. Okay, for the base, let's say we have NaOH and it dissociates, right, in water. We're going to have sodium plus hydroxide ion. So if it's a base, it's going to increase the concentration of hydroxide ion, okay? Now, as far as the acid goes, so let's say we have HCl, and that one is going to increase the concentration of hydrogen because it's an acid. It's not really hydrogen, it's the most correct one is actually hydronium ion. Just for the sake of understanding, you know that it is increasing hydrogen atom. So this is it. These are the different bases and acid definitions. Please make sure you know them, and you will be fine. As far as questions when they come up on your exam, you'll be able to you know exactly which one is which. I hope this helped, and happy learning.